Here is another lens problem. A candle is 12 centimeters away from a diverging lens. If the height of the candle is 15 centimeters and the focal length of the lens is 10 centimeters, where is the image formed and what is the size of the image? So let's start out by writing our knowns. So we're told that the candle, which is the object, is 12 centimeters away from the lens. So DO is 12 centimeters. We're dealing with diverging lens, so I'm going to draw it here so I remember what the lens shape is. Then we know that the height of the candle is 15 centimeters, so the object height is 15 centimeters. And the focal length of the lens is 10 centimeters, so F is 10 centimeters. The unknowns are where is the image formed, so that would be the image distance, and what is the size of the image, so we're looking for the image height. So let's draw a picture of this. Here we have a diverging lens, and it has a focal length of 10 centimeters. So here's F and here's F for the focal point. The candle is there, 12 centimeters away. And we know now that the object distance is this, that's DO, and we're looking for DI and the image height. We also know the height, so HO. Those are the things we do know. Now, remember also that for diverging lenses, the convention has the focal length of a diverging lens be negative. So while we were told that F is 10 centimeters, we have to remember that for a diverging lens, the focal length is negative, so it's negative 10 centimeters. The problems don't always tell you that the focal length is negative. You just have to know that that's the case. So we can start out with the lens equation. 1 over F is 1 over DO plus 1 over DI. In this equation, we know both F and DO, so we solve for DI. So we have 1 over DI is 1 over F minus 1 over DO, or DI is 1 over F minus 1 over DO to the negative 1. So that is 1 over F is negative 10, 1 over DO, that was 12 centimeters to the negative 1. And when you plug in the numbers, you end up with negative 5.45 centimeters. All right, let's stop and think. So for the image distance, we got a negative number. What does negative number mean for a lens? So we know that for a lens, the object distance is going to be positive if the object is in front of the lens, and the image distance will be positive if the image is formed behind the lens. And that is because beams of light travel all the way through a lens, and we expect the image to be formed on the other side. When the image distance is negative, it means that the image is formed on the wrong side of the lens, in front of the lens, on the same side on which the object is also formed. So with diverging lenses, we know that they only form virtual images, correct? And virtual images are on the wrong side of the lens, or in front of the lens, on the same side as the object. So the negative 5.45 seems a reasonable answer. So that was part A. Part B, now we're looking for the image height, so we can use magnification is HI over HO. So image height is magnification times HO, but the magnification is also given by the equation negative DI over DO, and I still have to multiply by HO. So image height then is negative di, which we found to be negative 5.45, divided by do, which is 12, and multiply that by ho, and that is 15. So I have two negatives. I have the negative here and the negative there. Multiplying that, we get a positive number. And if we plug in the numbers, we end up with 6.8 centimeters. So the height of the image is 6.8 centimeters, and it's a positive number. That means that the image is upright. It's the same as the object, and we know that upright images are virtual. So both of these signs here check out correctly in terms of our theory.